everyone. Now the next concept is the bending of a cyclist. Now if you are having a bicycle and if you are just taking a turn in a circular path, suppose, let me just draw the diagram. Suppose this is your bicycle. This is your bicycle. I hope so. Suppose I am not able to make a better diagram than that. Just assume that this is your cycle. This is not like that, but you can assume that. In this case, if the cyclist is taking a safe turn along a circular track which is having a radius of r and the velocity of the cyclist is equals to v, so in that case the cyclist itself provides the required centripetal force by aligning itself with some angle. That means when you are just taking a turn in a road, you just align your vehicle with some angle, right? Suppose if I assume that the vertical, it should be bent like the direction. In that case, bent cycle, yeah, it should be like that. Yeah, it will be better to draw the diagram in this case. Now if this is the vertical line, okay, and the cycle is aligned itself with some angle, right? We are just assuming that the angle that is equals to theta. Let me use some different ink here. The angle that the cyclist has aligned with the vertical axis, that is equals to theta. Okay, in that case the weight of the cycle that should work in this direction, that is equals to mass into gravitational acceleration, and there a reaction force should be in this case here in this direction. So now if the reaction force is having an angle of theta with the vertical axis, then we can say that what will be the direction of the components of that reaction force. That means I am talking about r cos theta and r sin theta. In the exam, the most important thing is that you have whatever you have just understood, you should apply, right? If you are not able to apply, then it's worthless. So that's why you have to understood. In that case, just remember one thing: the theta is between the reaction force and the vertical axis here. Now in that case you will think that the vertical axis will be r sin theta and the horizontal one, that should be r cos theta, but in this case this is not like that. Just rotate your phone in the anti-clockwise direction, you will get the concept over here at this time. Now in that case you have seen that the theta is aligning itself with an horizontal line, right, with the dotted line. Remember one thing: the line with which the horizontal line, in this case actually it is the vertical line, but if you just align your phone and just rotate it, you will see that it's a one kind of horizontal line, right? So along this line always the cos component will exist. Remember that one. On the line on which the theta is aligning itself, along the line only the cos component will exist. Now in this case I can write it down that component, that is equals to r cos theta, and r sin theta will be in this direction, that is our r sin theta. So that r sin theta that works in the inward direction, that will be balanced by the required centripetal force, that is of mv square by r, right? That is equals to the required centripetal force, that is equals to mv square by r. So I can say in this expression that r sin theta, that must be equals to mv square by r, right? And the upward force which is working here, that is of r cos theta, right? That r cos theta will be balanced by the weight of the object, right? Actually it should be in this direction. It will be better if you just draw it in this direction, it will be better. The line has just bent, but in this case the upward forces will be balanced by the downward forces, and in the downward direction only one force is responsible, that is the weight of the object. So you can say that the r cos theta, that should be equals to the weight of the object. Now this is the expression number 1 and this is your expression number 2. If you divide these two expressions, what will come? The previous one. If you divide these two expressions, what will come? That is of r sine theta divided by of r cos theta, that is equals to m v square by r divided by of m into g, right? So m should be eliminated, r should be eliminated. Tan theta, that is equals to v square by rg, and theta, that is equals to tan inverse of v square by rg. That is the required angle at which you have to take the safe turn, right? If the angle is greater than that, then what will happen? Your vehicle will be slipped down. Okay. Now this is the required expression. Now I'm just telling you again. In this case, whenever a cyclist is taking a safe turn along a circular path, it itself provides the required centripetal force, because when it is aligning itself with that angle of theta, now the reaction force is having two components. One is r cos theta and another is r sin theta. The r cos theta component is balanced by the weight of the vehicle, and r sin theta component is balanced by the required centripetal force, that is of mv square by r. So from solving from the solution of these two expressions, we have just got a relation, that is of tan theta equals to v square by rg. Okay, so the same case will be appeared for the banking of road. If you are having a vehicle and you are just banking on a road, taking a safe turn on a road, then the same expression will be generated. Okay, now let's move to the next concept, that is the case of simple pendulum. That concept also we had just discussed in the last class. That's why. Now, what is the concept of a simple conical pendulum? Let's see. Suppose I'm just drawing that. This is suppose your pendulum. This is suppose your pendulum. This is the bob of the pendulum, and it is rotating in the circular path, right? It is rotating in the circular path in the clockwise direction. In this case, we have assumed that. You can assume that also, that it is rotating in the anti-clockwise direction as well. Now it is having the radius of r with the vertical axis. It is having the radius of r with the vertical axis here. Now the length of it, that is equals to L, and the vertical height, that is known as h, right? Now in this case, when the bob of the pendulum is attached with a string, right? So this is the string actually by which the bob of the pendulum is attached. So if the string is there, there must be a tension that should work in this direction. If the bob is attached with a string and the bob is rotating in a circular motion, then there should be a tension in the string. So the tension in the string, that is equals to T. So there is an angle, right? There is an angle theta. So what should be the direction of T cos theta, T sin theta? You guys will think that T cos theta, T sin theta will be, you can directly place along the vertical height, but it will not be there. The tension is due to the bob of the pendulum. The bob of the pendulum is rotating in a circular motion. That's why we are able to analyze it in such a way that the components of that tension will be about the bob only. So in this case, if you just draw two parallel lines with respect to the vertical height, you can find out that. This is the concept of alternate angle. You guys have already studied in geometry. Now these are the two parallel lines. For the case of two parallel lines, where can I find out the alternate angle over here? Oh, sorry, there is a call which is coming over here. I'm so sorry. Now, in this case, whenever the bow of the pendulum is rotating in a circular motion, remember in this case the required centripetal force will be in this direction, that is of mv square by r, right? So in this case the angle should be, I hope there's very dirty, but I can do that one. Yeah, the alternate angle of this theta, that is equals to that one. I can say that angle is equals to theta. Again, if you just align your phone in the anti-clockwise direction, you can see that these are the two parallel lines, and theta is the required alternate angle over here. Now if the theta is aligning itself in this direction, now the vertical line actually along which the theta is working here, along this line t cos theta will be existed here, and in that direction t sin theta will work. Am I correct? I have already told you people that t cos theta will always work along the plane line. That means the line, it may be the horizontal line, it may be the vertical line, okay, but the line with which the theta is making it, right, the angle is formed with the help of that vertical line. So the cos component will only work along the vertical line in this case. So t cos theta will work in this direction, whatever is mentioned here, and the t cos theta will be balanced by the weight of the bob of the pendulum, right? So we are getting the two expressions again, that is t sin theta, that is equals to the required centripetal force, that is of mv square by r, and t cos theta, that is equals to m into g. So from solving of these two expressions, you will get tan theta is equals to v square by rg. The same expression you will get here. So in this case, what I have told you people, there is a task that is already assigned, that you have to calculate the linear velocity, the angular velocity, the tension in the swing, and the time period of revolution. I need these four things on the next class on 21. Okay, so now I'm just concluding the session at this point of time. I hope it is quite understandable for you people. If you have not understand anything, then just tell me, I can clarify it. Okay, thank you.